Hello, everyone. My name is Soham. Thank you so much for being part of this session. I hope you're having a great time at the conference. In this session, we'll look at the EcoFlow package. It's just a project name for the Prefect workflows for scaling acoustic fisheries survey pipelines. It's a package developed using Prefect orchestration tool, which can streamline the processing of sonar data. Now, while this package is tailored for sonar data processing, the architecture itself is very flexible, and thus the package can be extended beyond sonar data to accommodate other data types and processing APIs. For example, you can use this package to orchestrate some Python scripts which are dealing with geospatial data or even relational data. So this session is definitely useful for data as well as software engineers who are interested in parallel data processing or want to implement dynamic workflows using standard Python and seeking functionality like scheduling or a workflow kind of a tool. And if you're a researcher or someone actively involved in sonar data or acoustic data, this session is just tailored for you. We'll explore how EcoFlow can be a game changer in your work and provide solutions to the current challenges that this industry is facing. It was Don Sedivan, one of my colleagues, who started this project, and I would like to thank him for laying a solid foundation and supporting me throughout. I worked on this project as part of my internship at the eScience Institute, which is here in Seattle. I would like, I would also like to acknowledge Valentina and Wu Zhang for their continuous support and for giving me this opportunity. Okay, before getting in the project, here's a very brief background about me. As no one already introduced me, I'm currently pursuing my master's degree in data science at the University of Washington. I have 3.5 years of experience as a software and data engineer. I worked at Deloitte and Majesco, and of course, I have gained a lot of different expertise in various aspects like application development, cybersecurity, and more recently, data pipelines. Currently, I'm working with AWS as part of my capstone project to address shortcomings in current commodity hardware testing methods. I'm trying to enhance the decision making behind onboarding new hard drives in S3. The end result would help AWS in optimizing S3's storage and performance. And of course, I'm interning at eScience Institute for this project and working towards adding more capabilities to this package, something like real-time data processing and adding more deployment options in future. All right, moving on. Here is what we have on the agenda for this session. We'll kick off the session by addressing the two most important questions, that is, why we need this and where can this be used. Basically, we'll try to understand the purpose of this package. I will also give a brief background of sonar and acoustic data processing. Following that, we'll see a quick comparison between Airflow and Prefect, which should give some insights into why we opted for Prefect over a popular tool like Airflow. Our journey continues with a deep dive into EcoFlow's architecture, complemented by a live demo showcasing its functionality and deployment options. Finally, is there a question? Okay. Finally, we'll look at some solutions that EcoFlow offers for common challenges in creating such dynamic data workflows. And then we'll open the floor for any questions. So without the further delay, let's see how EcoFlow can be a game changer and streamline the data processing. EcoFlow offers many use cases from oceanography studies to identifying species and tracking their behavior. It can also be used in monitoring fish population. One of the example could be Fisheries group, with whom we collaborate, since they lie between fishery scientists and agencies and data scientists. This project could be particularly useful to them since they do something called as fisheries stock assessment. For someone who doesn't know what NOAA is National Ocean and Atmospheric Administration. It's a group which continuously researches and does things related to ocean and atmospheric. Lastly, EcoFlow is customizable, so research groups can come up with more processing stages tailored to their unique requirements and would still be able to use this package. This adaptability also facilitates the seamless switch between different data types, which I was talking earlier. The major reason is the absence of any hard-coded constraints, which helps EcoFlow fit into almost every changing need. Now we know the spectrum of use cases that the EcoFlow package can cater to. Let's have a look at what exactly is sonar and acoustic data processing and why do we need it. Echo sounder is basically a device, as we can see in the diagram. It's attached to a ship. It uses sound waves to measure the distance in the ocean or identify objects underwater. This can give us some vital insights into the underwater environments. Over the years, there have been many ships and autonomous devices. Autonomous devices are basically a device without a human intervention and can either cover a specific area or be standalone in the sea in order to collect sonar data. This data collection has been going on from years now, resulting in a very big data set, which is around 250 terabytes. And since it has been going on since many years, and there have been many tools which are used to record such data, these tools are using different encoding, and due to that, it possesses a great challenge to process such data. Additionally, there might also be a need for different workflows to process this data, since people might be interested in getting different insights from the same data. So current tools are not capable of handling such data and such workflows. Thus, we need much better compute as well as some tools which can orchestrate well. Within eScience Institute, I'm working with a group called EcoSpace Group, which focuses on marine science and technology. And we as a group are committed to developing an open source Python software toolbox designed to transform sonar data into valuable insights. So we are offering a set of packages basically which can help end to end, right from processing the raw data to having visualizations and machine learning. Okay, so now that we have our why and where figured out, let's delve into EcoFlow. This diagram would be able to give a better clarity of what exactly the role of EcoFlow is. As we can see, the first step is to convert the raw acoustic data into a cloud optimized data format, something like a ZAR, which can be processed by EcoFlow. We then aggregate the processed data into manageable chunks, followed by calibration, which is addressing the variations in the recording environment, something that we were talking in the previous slide. Once we have the processed data, we can extract the desired features from it. This may involve gathering biological estimates and combining the ML capabilities. Lastly, to showcase these results, we can also visualize them and have interactive graphs for our better understanding. All of these steps are handled by different packages which are developed by our group. Crucially, EcoFlow serves as the orchestrator and seamlessly manages and coordinates these processes, that is, all the packages. Its design not only streamlines the workflow, but also provides users with significant flexibility in shaping their data processing journey. So we used Prefect as the backbone for EcoFlow, which is a hybrid orchestration tool offering both a paid as well as an open source version. It shares similarities with Airflow, which is a very popular tool. For those unfamiliar with both of them, both are basically tools which can be used to orchestrate or basically manage the execution of a data pipeline. With Prefect 2.0, it became very easy to use it even for new users because of its Pythonic nature. The ease of integrating with standard Python code, native support for distributed processing libraries like Dask and Ray. If you don't know what is distributed processing libraries, we'll delve into that later because we are going to see a demo as well. And thirdly, the ability to create dynamic workflows, that is allowing flexibility in defining and modifying the pipelines on the go. These three things were transformative to EcoFlow's development and certainly gave an edge over Airflow. And thus we decided to go with Prefect rather than Airflow. So talking about Prefect, Prefect uses two main concepts that I wanted to introduce. That's flows and tasks. So pipeline is basically logically separated into flow and task. A flow is a broader concept and can have multiple tasks or subflows within it. So as we can see that flow 1 has a subflow, uh, which is flow 2, and then we move on to flow 3. So, and we have 3 tasks as well. Tasks are discrete unit of work which can perform some, for example, API calling or some data cleaning process or something like that. And these tasks can be, of course, reused by flows, which we can see that flow 1 and 2 are sharing a task 2. So it also allows reusing of tasks, basically. Okay, let's take a closer look at the Prefect architecture to understand its working as EcoFlow aligns with this model. We have 3 main blocks, that is the Prefect cloud. There's a execution environment, which consists of an agent and the flow code. And then we have various cloud integrations as well. So code once orchestrated with Prefect kicks off an agent that is basically some deployable, which can take the input and execute the pipeline. Pipeline is nothing but the flow code here. When using Prefect Cloud, this agent communicates with Prefect API on the cloud, enabling centralized workflow control. Whereas in offline scenarios, we can spin up a Prefect server in our local environment. Local environment is nothing but our laptops or desktops, and the agent can communicate with that server. There is also a component called Cloud UI that interacts with Prefect. And this Cloud UI, or even in local, we have a UI. This UI basically provides us a dashboard to monitor all the runs and scheduling tasks. And Prefect also seamlessly integrates with a wide array of cloud platforms and services and offers multiple input and output options along with varied compute sources, something like Snowflake, Databricks, AWS, Azure, GCP, just to name a few most popular ones which are used in data pipelines or data engineering. Now let's explore the EcoFlow architecture, which bears a lot of resemblance to Prefect as it serves as the backbone of the package. Similar to Prefect, EcoFlow can connect to most of the cloud technologies, spin up an agent to execute the flows, and communicate with Prefect API to have a centralized control. EcoFlow takes raw files and YAML configurations. Raw files are nothing but the input files here. And the YAML configuration aids in defining 2 key aspects. I mean, there are 2 YAML files basically. One is the data source YAML file, which is helping us specify the source, destination, and how is the formatting of the data. The second is used to define the execution order, which is determining which steps need to be executed and the configuration for each step. I will go into much deeper into these files when we go to the demo section. Coming to the EcoFlow architecture, like the core part itself, some of the components that EcoFlow has are listed in the figure. As we can see that there is EcoPipe, EcoShader, EcoRegions, and Sonar NetCDF for EcoPipe Checker. All of these are modules that are integrated with EcoFlow, and We can also define some custom processing steps and simply add the modules to the YAML configuration. These modules basically are nothing but APIs which help us process the data. For example, EchoPipe can be used to process the raw data. EchoShader provides us with visualization capabilities, and EchoRegions have the ML libraries. Then we have libraries which are marked in blue. Dask is one of the library which we are using for distributed computing to execute bunch of tasks on a cluster of machine. For logging, users can either add or extend a YAML configuration file provided to log locally, or they can also use specific logging services or server like AWS CloudWatch or Splunk. And finally, we have some programming paradigms which are used to make the workflow simpler and robust. AOP is one of them, which is aspect-oriented programming. It is useful to log or have flow validations and having a centralized error handling basically. For those unfamiliar, AOP is a programming paradigm that helps in executing some code before and after a function. Basically, it's like a wrap around a function. Ekflow also has REST API support. So it can communicate with the REST API endpoints provided by Prefect and extract pipeline execution metadata. Prefect 1.0 was using GraphQL, but from Prefect 2.0, they're using REST API. So we have the REST API support as well. EchoFlow also incorporates a basic rule engine to ensure that while we provide flexibility, we don't allow the execution of invalid flows. Although we aim to give users full control over what they want to execute, the rule engine helps to define some structure or order to the execution. Okay, the last section before we start the demo, let's have a look at the deployment options that we have. EchoFlow can be effortlessly deployed on various platforms, whether it's a virtual machine, something like cloud, or local machines, or even with Docker containers. In Prefect, there's a concept of blocks. I'll go into deep depth when we go into the demo section. Blocks makes the deployment very easy. We can create a storage block to store our code or execute environment variables and execute this storage block using an infrastructure block. So infrastructure block is nothing but, for example, a EC2 instance, for example, which can help you execute your storage block. And setting up the environment is also a straightforward process, but since the package is still in its early stages, you need to clone the repo and install the necessary dependencies within a virtual environment. Once the environment and repository are set up, the next step involves configuring two YAML files, which I was discussing earlier, which will help you to, one file will help you determine the source and destination of the data. One will determine what steps you need to perform on that data. With these configurations in place, we can harness the CLI capabilities, that is command line interface capabilities offered by EchoFlow. That is, we are offering some commands basically, which help you set up the project in your system and also help you configure your credentials. For example, AWS credentials, if you want to set up an EC2 and you want to have credentials locally. So EchoFlow's commands can be used to set up these credentials as well. This enables us to create a working directory and set up prefect profiles as well seamlessly. The versatility of EchoFlow inherited from Prefect allows us to choose between running the flows locally by initializing a Prefect server, or you can utilize a Prefect cloud account for more extensive tasks. On the similar lines, we can then opt for local computing or cloud computing, something like, again, EC2, but we can also deploy it as a systemd process. Systemd is basically, it allows EchoFlow to run as a background service. Essentially, your EC2 will act as a computer server, and it will take all the flows from a work pool and execute them whenever we want to schedule something. Okay, let's go to the demo section. So I have already cloned the repo, and I also have set up the environment. What we can do is we can run the command echo flow init, and this will basically create this will basically create some folder structure internally for in order to store some JSON metadata inside, and this will be used while processing. I'll go to the test section. We have two notebooks here. One is the local notebook, but there is also AWS example, which is, so I'm starting from how to clone the repo, how to make the environment, and then how to initialize Prefect, how to initialize echo flow, how to create S3 bracket, store your credential. I've written everything in detail in that notebook. So you can also check out this notebook. I've added the GitHub link in the resource section of this meet. Going to the offline section. So we have already done installation and environment. We also did echo flow init, which is initialization of echo flow. I also have the Prefect profile created already. So I'm just going to start the Prefect server here. So Prefect server start. And this will start a server locally, which is at port 4200. Then we'll load two YAML configuration files. The first one is, so what we are doing here is we are trying to calculate the target strength from the raw files. So we have two stages. One is open raw, and the second one is computing the target strength. For this, we are using an active recipe name that should match with this target strength, the recipe name. So the logic behind this is that we can have multiple recipes in the same YAML file, but we can configure active recipe and then just use that recipe for that specific run. I'm going to use a local task here. So if I set it to true, it basically means that it will internally create a task cluster, and number of workers is 5. So it will create 5 number of workers. And then this is just specifying which module that I want to execute. And then we have some options, that is whether we want to use the offline version, use the offline files available. Do we want to save the offline files? Like when we fetch the raw files from the source, do we want to save them? And then we have similar for compute TS. There are also other options available, and you can go to the documentation. Okay. You can go to the pipeline documentation. Okay. Yeah, here. So you can see that there are multiple options which you can configure for each basically a stage, and then you can have prefect configurations as well. You can specify the number of retries that you want, etc. And you also have there's some glitch. And then you have this data store config YAML file. So this is basically used to mention your source. This is the S3 URL that I'm going to use, and it will fetch all the raw files which matches this regex. And this is the ship name, survey name, and sonar model that I'm going to use to fetch the data. And we are also defining some transit. Since this is just a test, I'm going to pass on that all the files belong to a same group. Transit is basically a group. And here's the output folder that I'm going to use. And I'm going to say that, okay, we want to retain the output. And if the destination already has the output, we are going to overwrite the output, which is basically override is equal to true. Okay, so let's fetch all the files from here. We are just fetching the name of the files. We're not actually fetching all the raw files from the S3 bucket. Here, I'm just gonna go 10 because 100 will take a little more time than we have right now. And so this basically created a text file here with 10 names of files which we want to process. And I'm gonna pass those that file as an input to our function. And as we can see, this folder has been created. I can show maybe your. So as we can see that raw files are downloaded and ZAR files are created from that. So it took about 25 seconds to execute around 300 MB of data. And as you can see, the DAS cluster, which I was talking about, it basically divides your processor, I mean, the local computer into some number of clusters. There's one master cluster as well, master node as well. And we had 5 clusters to process this. And we can see that all 10 of them are done. Okay. Let's see the dashboard as well once of how it looks. So this is how the dashboard looks like. When you execute some flows, it should come in the flow runs. It should display if there are any failures, if there are any success, and what flows that you have. You can also create some deployments, something like I have created here. You can see EC2 and ECS deployment. Then we have something called as work pools, which is basically when you schedule a flow, a new job is created in the work pool. From that work pool, your EC2 instance or wherever the agent is, that picks up your task. And this is what I was talking about, the blocks. You can configure your credentials here. You can just click plus and go on and have your AWS credentials set up, which can be used to basically execute your flows on AWS. And yeah, that's about it for this session. I hope you enjoyed this session.